Okay. Good afternoon, Bhute. Today we are going to start electrostatic field. It is a new lesson. Actually, it is one field lesson in our syllabus. Okay. Okay. If we consider force fields, we have to learn three kind of force fields in our syllabus. Okay. First one is electrostatic, gravitational, electrostatic, and magnetic. Gravitational, electrostatic, and magnetic. Electrostatic and magnetic. Those are the those are three fields that we are going to learn in our syllabus. Okay. So now we are discussing about force fields. Force field, but among those three fields, I have chosen electrostatic fields to do first because after doing this electrostatic field, we can start current electricity as well as magnetic fields because all the three units are interconnected. Okay, what are those? Electrostatic field, then I'm going to do current electricity, then magnetic field. These are the order that I am going to teach you. Okay. Though if we consider these three units are interconnected. These three units are interconnected. Actually, I'm calling these three units as electricity. Because all the three units are interconnected and it is about electricity. Okay. So if we consider this electricity part, that means about these three units, there will be 14 to 15 MCQs. 14 to 15 MCQs. Very huge number. 14 to 15 MCQs. In MCQ paper, in electrostatic field, there will be 6 or something, 5 or 6. Then current electricity again 6 to 7. Then magnetic fields 5 to 6. Okay. Therefore, more than 14 to 15 MCQs will be there. Okay. So this is very huge number. This is very huge number means because one mark for MCQ means there is a 1 mark in final paper, no? Then this is the MCQ. Then there's a structured essay question. Structured essay question from current electricity part. Structured essay one. Then there are 2 essay questions. There are 2 essay questions. So the one is from current electricity, other one is from fields. Fields may be either magnetic field or electric field or gravitational field. Therefore, if it is a magnetic field or electric field, then there are 2 essay questions. If you are given gravitational field, then there is only 1 essay question. So there are maximum 2 essay questions, minimum 1. So if we take this part, That means electricity part. This is very critical lessons in your syllabus. Okay, because you are given a lot of marks, for this session. Actually, I am teaching this part. I am teaching these 3 units as a bundle. As a bundle means most of them are interconnected. Therefore, sometimes, suppose in electrostatic fields we have to teach capacitors, but I will teach you after doing current electricity. Otherwise, you won't get that one. Okay. Therefore, those 3 units are interconnected. Due to this reason, I will teach all the 3 units as a bundle. Okay. If anyone can understand and can proficient with mechanics and electricity part, definitely he can get a pass. Okay, definitely he can get a pass, because in mechanics there will be 12 to 13 MCQs. Then again, one is structured, one is equation, as well as electricity part. Therefore, very critical part. Okay. Okay. Everyone, please look at the board. Now we are going to discuss about force fields, Putha. Force fields. Okay. Tell me, anyone. What is a force field? What is a force field? Can anyone guess? What is a force field? What is a force field? Force field can? Yes, very good. A region where force acts. Very good. Suppose now there's a pen, no? If I release this pen or drop this pen, what will happen? If I release my hand, what will happen? It falls down, no? It falls down. So that means this pen, sorry, this pen has changed his position, no? Initially, it was at this level. After I release my hand, it falls down. Okay? So that means the position has been changed. So if the position has been changed, that means there should be a unbalanced force, no? Unbalanced force. There should be unbalanced force. Definitely there should be unbalanced force. Otherwise, Newton's first law will be wrong. According to Newton's first law, if there is not an unbalanced force, definitely any object should be at rest or moving along a straight line with the constant velocity. No? So if I release this object, definitely what will happen? It falls down. That means there should be unbalanced force. But can you see any contact? Can you see any contact between? Actually, there's an unbalanced force towards the Earth, no? But did you see any contact between Earth and this pin? Did you see any contact? No, you didn't see, no? No. Same kind of example. I can deal with the same kind of example. Two magnets. If you take two magnets, this is a game. This is a game, no? I think you have played this game. If you take two magnets here, if you take two magnets and if you bring one magnet close to other, then what will happen? If you bring one magnet close to other, you can see this one repel, no? This one repel. This one repel, no? Or if you take the other part, other side, if you take the other side, it will be attracted. It will be attracted. Okay. Therefore, in this case also, you didn't see any force, no? Actually, even you did not touch it, touch this magnet, no? But what will happen? What happened? This magnet repel or attract due to some force, no? But that force, actually, we cannot see that force. We cannot see that force. Okay. Therefore, force field is something like that. Force field is something like that. Okay. Actually, force field is a region. It's a region in a space. Actually, it is a region in a space. So there's some masses or charges can experience some forces due to this region. Okay. So, and there's no need any contact between any objects. Okay. So, force field is a region. It's a region in a space, is a space that can experience some force. Force on masses, then charges, some charges, something like some objects having some specific properties. Mass means some property, charge means some another property. So some objects having some specific properties experience forces without any contact in a force field. Okay. Therefore, force field is a region in a space that some object experience forces without any contact, And that is the most important thing. And okay, write down this thing. Write down that one. The main topic is force field. The main topic is force field. Force field. Force field. Okay. Right under that. Right under that. Force field. Force field in physics. Force field in physics refers to a region in a space where an object where an object with mass, comma, electric charge, comma, or some other or some other property. Experience a force. Experience a force. Experience a force. Okay. Within the bracket. Especially without any physical contact. Especially without any physical contact. Close the bracket. Close the bracket. Okay. Then another rule, another paragraph. We have to learn three types of force fields. Three types of force fields in our syllabus. Okay. Write down. Force fields. There are three types of force fields. First one is gravitational. Second one is electrostatic. Third one is magnetic. Okay. Shall I erase? Thank you, Uday. Okay. Then write a topic, the main topic, electrostatic field. Okay. Listen to me very carefully. Everyone, please listen to me very carefully. Okay. Suppose, okay. Actually, you can, I think you can remember the atomic core material structure that I have discussed in heat lesson. No? According to that structure, almost all the materials, or almost all the objects are made of some small atoms or small particles. Okay. Actually, all the materials are made of atoms, no? Atoms. Okay. If you take an atom, there are subatomic particles. Okay. Actually, we can divide the atom further, no? We can further divide this thing. Therefore, if I divide this, if I divide the atom into subatomic level, actually, there are several subatomic particles. There are several subatomic particles. Okay. Among those subatomic particles, there are some charged particles. It is called electrons and protons. Electrons and protons. So every atom consists of electrons and protons. That means subatomic particles. Okay. And those subatomic particles have charge. Okay. So electrons has charge, proton has charge. Those are having charge. Okay. That means every materials are made of atoms, and atoms are made of subatomic particles, such as electrons and protons. Those subatomic particles have charges. That means inside every material, there are charges. Okay. Electrons and protons, there are charges. Okay. So every material have charges, means every material can have electric properties. Every material can have electric properties because all the materials are made of small charges. Therefore, every material can have electric properties. Did you get my point, everyone?
Yes.
Thank you. Okay. Now you actually now you know about some properties of electrons and protons. Actually, you have done this thing in chemistry. Okay. Have it. About electrons. I think you know about this thing. All the materials are made of atoms, no? Atoms. Those atoms are bonded by intermolecular bonds. Okay, we have discussed this thing in heat. Okay, those atoms are bonded. Every atoms are bonded by intermolecular bonds. Those intermolecular bonds may be covalent bonds, sometimes metallic bonds. So there are various type of bonds. Okay. So if those bonds are covalent bonds, that means suppose this is the bond. This is the bond. Okay. So if it is a covalent bond, that means electrons are shared with each material or each atom through a bond. That bond is called as covalent bond. Okay. Therefore, those electrons are bond together means bond by those covalent bond. Due to this bond, those electrons actually cannot move here and there. Okay, because they are bonded by covalent bond. That is number one. There are another type of material, another type of bonds. That bonds are called as metallic bonds. In metallic bonds, suppose Fe. In metallic bonds, actually, those electrons are not bonded with covalent bond bond. Okay, those electrons can move here and there, and due to this reason, there's an electron cloud. Throughout metal as a metallic structure. Metallic structure. Oh, there's electron clouds because these electrons can move here and there. Within this lattice, these electrons can move. Those are movable electrons. But those are not movable electrons because they are bonded by covalent bonds. Therefore, those are not movable electrons. Okay. But in nature, metallic bonds have movable electrons. Okay. Have. Therefore, electrons in material can be divided into two major categories according to their mobility. Okay. Some electrons cannot move and some electrons can move. You see. And some electrons are bound together with very strong bonds and others can easily move throughout the material. Okay. Therefore, according to their mobility, we can divide those electrons into two categories. And so normally those kind of electrons are called as stationary electrons. Those are movable electrons. Those are movable electrons. Those are stationary electrons. Okay. So charges can therefore charges within the material or charges within an atom can be divided into two basic categories according to their mobility: stationary and movable. Stationary and movable. So there are two types of charges: stationary and movable charges. So according to their mobility, they have different kind of properties. Different kind of properties. These electrons have different properties than these electrons. Okay. But due to these two type of electrons, these two type of charges, not electrons, charges, there can be force field. There can be force field due to stationary charges as well as movable charges. Okay, stationary charges means charges in actually it is not the charges in covalent bond. And that is an example only. Okay, if any charges is not movable, that means it is a stationary charge. Okay, it is a stationary charge. And it may be object. Okay, now I have discussed that thing in atomic level, but it may be object. Okay, the stationary charge may be object. And I have discussed that thing in the atomic level. Okay, so it may be a atomic level material or it may be object. Okay, so charges according to their mobility, charges can be divided into two categories: stationary and movable. Okay, so according to their mobility, they have different kind of properties. And different kind of properties, but both of them create force field. Both of them create force field. Stationary charges as well as movable charges both create force fields. Force fields. Okay. So if there is a force field, suppose this is a stationary charge. Suppose this is a stationary charge. Okay. Now this is an object. Okay. I have discussed this thing in atomic level. Now this is an object. That means collection of lot of atoms. Okay. Suppose this is a stationary charge. Due to this stationary charge, there will be a force field. There will be a force field. Okay. So if I bring minus charge or negative charge closer to this object, definitely there will be attractive force, attraction force. Okay. If I bring positive charge here closer to this object or this charge, definitely there will be a repulsive force. Okay. Therefore, this stationary charge creates a force field. Okay. So force field created by stationary charge are called as electrostatic field. What is electrostatic field? Electrostatic field is a force field that is created by a stationary charge. And this force field creates forces on charges only. So there due to electrostatic field, there is no any force on mass. Okay. Therefore, this electrostatic field creates or exert forces on charges only. Okay. Did you get my point? එහෙනම් අද charges වලින් තමයි මම force එකක් දෙන්නේ. masses එකම ගෙනාව කියලා force එකක් හම්බ වෙන්නේ නැහැ හරිද? Okay. හරි. Therefore, this is called as electrostatic field. Electrostatic fields are created by stationary charges. Due to this electrostatic field, there is a force exert on charges. Then, if there's a movable charge, if it is a movable charge, normally we call it as a current. Current is normally that is a word of movable charge. If there are movable charges, normally we call it as current. So if there's a current, due to this current, definitely there will be a force field. This force field is called as magnetic field. Magnetic fields. That's why I told you earlier. These three units are interconnected: electrostatic field, current, electricity, and magnetic fields. All are interconnected. Therefore, normally I consider all of them as one unit and teach you according to that. And therefore, due to charges, there are two kinds of force fields. Yes, definitely. Not only movable charges, not only stationary charges, electrostatic field can affect or can exert a force on movable charges. Definitely. We will discuss that thing. Right? Force field, actually, not only electrostatic field, but also magnetic field exert forces on movable charges as well as stationary charges. But look at this. If we consider charges according to their mobility, I can divide them into two categories: stationary and movable. Stationary and movable. Okay. Due to stationary charges, there will be a force field. We call it as electrostatic field. Electrostatic field. Static means stationary. Therefore, that field is created by stationary charge. Okay. So, due to stationary charges, there will be a force field that is called as electrostatic field. The force field created by a movable charge, normally we call it as current, movable charge. Stationary charge, movable charge. Charges, no charges. Normally we call that it as current. Current. Due to current or due to movable charges, there will be another force field. Normally we call it as magnetic field. Both electrostatic fields and magnetic field exert forces on charges. Both are exert on charges. Okay, so if there are metal, if there is a metal, metal means there are a lot of charges inside that metal. Therefore, if we keep a metal, within a magnetic field, definitely there will be a force. Okay. You can create, actually, you have that experience. If you may bring a magnet, if you bring a magnet closer to metal, what will happen? It will attack. It will attack. So that is due to the magnetic field, and that is due to the force exerted by magnetic field on the charges inside that metal. Okay. Therefore, both electrostatic field as well as magnetic field exert forces on charges or objects that may carry charges. Okay. Hi. Okay. Now we can note down the thing. Everyone, please let me know. Did you get my point? Everyone. Others?
Yes, sir.
You? Hi. Okay. Then write a topic, electrostatic field. Electrostatic field. Electrostatic field. Under that topic, write down this thing. Electrostatic field is the force field. Is the force field that exerts forces on charges and created by a stationary charge.
So can you repeat by and related by?
uh, that exert forces on charges and created by a stationary charge and created by a stationary charge.
Thanks.
Write in another paragraph. According to their mobility, charges can be divided into two categories. Charges can be divided into two categories. Both categories create force fields. You can note down this thing. Okay. Shall I erase this one?
Okay.
Good. Okay. Hi. Now you can clearly understand now all about charges. Yeah, charges. So we have to have some knowledge about charges. So now we are going to discuss about charges and so what is a charge? How to make a charge object. So what are the method of making a charge object? Those kind of things we will discuss under the charges. Okay. Right. Write down under this Uh, therefore, therefore, charges are the basic unit. Therefore, charges are the basic unit. that create electrostatic and magnetic fields. Electrostatic and magnetic fields. Okay. Correct. The unit of charge means charge is measured by Coulomb. Coulomb. It is measured by Coulomb. Coulomb, that is the name of a scientist. That is the name of scientist. Therefore, the symbol is capital C. Capital C. Symbol is capital C. Capital C. Have it? Have it. So, unit of charge. Write a note. Unit of charge is Coulomb. Coulomb. The symbol is capital C. Coulomb is a very huge value of it. Coulomb is a huge value. Right. Okay. So now we have to discuss about charges. Okay. Okay. As we discussed earlier, every material. Please look, may I look into the board again? Please look into the board again. So as we discussed earlier, every material made of atoms, atoms. All are made of atoms. And those atoms are made of subatomic materials. Atoms are made of subatomic materials such as electrons and protons. And then there are another subatomic particles. And so those electrons and protons have charges. Okay. So every material, each and every material, that means each and every materials having charges inside those materials. Okay. So according to number of electrons and number of protons within that material, we can divide a material. We can divide materials into two basic categories. Two basic categories. What are those? Neutral material and charged material. Neutral and charged material. So how to divide this one, neutral and charged material? According to the number of electrons and protons inside that materials, we can divide those materials into two categories, neutral and charged. Neutral and charged. So tell me then, what is a neutral material? What is a neutral object? Neutral.
No charge.
No charge. So if there's no charge, then what should be the requirement to be fulfilled? Tell me.
The number of protons and electrons should be same.
Very good. That is the reason. Very good. Equal number of, yes. Answer is correct. The number of electrons and number of protons should be equal. Okay. If any materials have an equal number of electrons and protons, the net charge is zero. So if the net charge is zero, those kind of materials are called neutral material. Okay. Then if there is an inequality between electrons, number of electrons and number of protons, then there will be a net charge. So those kind of materials are called charge material. Charge material. Then tell me how to create a charge material. How to create a charge material? Can anyone tell me how to create a charge material?
Either the number of protons is greater than by removing an electron.
By removing an electron. We now remove electrons. Okay. What about protons? What about protons? Why are we telling about electrons? Can't we remove protons? Can't we remove protons? Why?
They are in the nucleus.
Yes, very good. Yes, protons are in nucleus. Therefore, we cannot touch protons. We cannot touch them. Okay, so if we want to charge any object, you have to do that thing with electrons. Okay, so we cannot touch protons. Actually, we can. If we touch that thing, then it will be a nuclear process. Okay, therefore we are not considering that thing. Therefore, we are not going to touch protons. So if you want to charge an material, charge an object, that means either the number of electrons should be higher than the number of protons, or number of protons should be higher than the number of number of electrons. So if the number of electrons is the number of protons is higher, if number of protons is higher, that means number of electrons is lesser. So we have to remove electrons from the material. Okay. So if we remove electrons from a material, then what will happen? Suppose initially there are 10 protons and 10 electrons. 10 protons and 10 electrons. So the material was neutral because number of electrons and number of protons were equal. Now I have removed 2 electrons from this bundle. Now what will happen? Then there will be 8 electrons and 10 protons. 8 electrons and 10 protons. That means there will be plus 2 net charge. Plus 2 net charge due to this removal. Plus 2 net charge. So that is the way of giving a charge to an object. By removing or adding, you're gaining electrons to an object. Okay. So if you want to make a negatively charged object, if you want to make a negatively charged object, then you have to give some electrons. You have to give some electrons to this material. Okay, we will discuss how to remove and how to give electrons to an material, to an object. We will discuss the thing, but as a concept, we can tell you, we can conclude, if we want to have charge object, we have to remove or add electrons. We have to remove or add electrons. Okay. We cannot touch proton because they are in the nucleus. Therefore, we can do removing or adding electrons only. Okay. Did you get my point? Hmm? Here now?
Yes.
Yeah. Hi. Now we have to write the atomic structure. Right. Then write a topic, atomic structure. Atomic structure. Atomic structure. Write down this thing. Atoms are made of charges such as electrons and protons. Atoms are made of charges such as electrons and protons. Therefore, in every atom, there is electrical characteristic. There is an electrical characteristic. There is an electrical characteristic due to these charges. According to their electrical properties, charges can be divided into, electrical properties. Objects can be divided into two major categories. There's two atoms. Neutral, charge. Neutral and charge. Neutral means number of electrons. Number of electrons is equal number of protons. Number of electrons equal number of protons. In here, number of electrons unequal number of protons. Unequal number of protons. Further to that, we can tell it number of electrons. If number of electrons greater than number of protons. If number of electrons greater than number of protons, that means it is negatively or positively charged. Negatively or positively charged. If number of electrons is greater than number of protons,
Negatively.
negatively charged. Negatively charged. If number of electrons lesser than number of protons, that means positively charged. Okay, look at that. Okay. Write down under this another topic. Neutral objects. Neutral objects. Neutral objects. Neutral objects. After writing this one, write a topic, neutral object. Neutral object. Write under this, right under there, neutral objects. If the number of positively charges, the numbers of positive charges numbers of positive charges equal to the number of negative charges. Number of negative charges. The atom or objects, the atom or object is said to be a neutral object, as there isn't any net charge, as there isn't any net charge. The next topic is charge object. Charge object. Okay. In a neutral object, again, Ne equal NP. Ne equal NP. So, if we can remove or add, if we can remove or add electrons or protons, while keeping the other unchanged, then there will be a net electric charge. Right, in another paragraph, protons cannot move easily.
Sir, please repeat that, sir.
Protons cannot move easily. Protons cannot move easily. Protons cannot move easily as they are in the nucleus. But electrons are movable particles. Therefore, we can add or remove electrons we can add or remove electrons from an atom making it a charged object okay. Suppose we have removed electrons within that material. That means the number of electrons now is lesser than number of protons. And that means the number of protons is higher, so this will be positively charged. Then this one. Now electrons are added to this material. That means there will be a excess electrons. Now the electrons are added. So if electrons are added, that means the number of electrons should be greater than number of protons. So the number of electrons is higher than the number of protons. That means this should be negatively charged. Did you get my point? Same another.
Yes, sir.
So now you have to draw this one, Putta. Draw this one. First one is removing electrons. Second one is adding or gaining electron. Ada. Makan ada. Instructed basic gestures that you can do actually. So there are some limited number of MCQs. Sorry. So I think it is better to do some classified MCQs in this period. That means suppose you have covered first two lessons, that means mechanics and unit and dimensions. Now you can go for the classified MCQ books and do all the MCQs from 1993, 1990. I think MCQ English mediums classified books from 1990 to 1920, 1990 to 2020, something like that. Like single medium එක 1983 වල වගේ දැන් තිබ්බනම් ඉංග්‍රීසි මීඩියම් එක මම දැක්කේ 1991 හරි 19 එතන තමයි පටන් ගන්න. So at least ඒක හරි තියාගන්න. ඒ නිසා past papers නම් නිතරම කරන්න. හරි. නිතරම කරන්න කියන්නේ මම සාමාන්‍ය කියන්නේ දැන් අපි කොහොමද දැන් මේ quick recaps අද දෙන්නේ නැහැ. ඒක මේ quick recaps ටික අපි කරනවානේ. දැන් quick recaps වලදී අපි මම ඔයාලට කිව්වා අනිවාර්යෙන් පොතක් එකට තියාගන්න කියලා. quick recap කරන්න පොතක් තියාගන්න. මොකද මේ සහ ඊළඟට රිවිෂන් එකේ මම දෙන papers කරන්න පොතක් තියාගන්න. හේතුව කවදා හරි exam එකට යනකොට එතකොට ඔයගොල්ලන්ට ඊට කලින් බලා ගන්න පුළුවන් මොනවද වරද්දගෙන තියෙන්නේ, මොනවද අපි දීපු ඉන්ෆෝම් පොයින්ට්ස් මොනවද තියෙන්නේ, ඒ වගේ දේවල් ලියා ගන්න පොතක් තියාගන්න. ඊළඟට මම කොහොමද ක්වෙස්චන් එක සෝල්ව් කරේ කියන එක නෝට් ඩවුන් කරගන්න තියන මට වඩා ලේසිකම වලින් ඔයගොල්ලෝ සෝල්ව් කරලා තියෙන්න පුළුවන්. හරිද? ඒක මාර වටිනා නැහැ. ඔයගොල්ලෝ මට වඩා ලේසිකම අනන්තවත්ම දැකලා තියෙනවා. මට වඩා ලේසිකම වලින් හදන ළමයි ඉන්නවා. හරි? ඒ නිසා ඒක තියාගන්න. මම හදන විදිය මොකක්ද කියන්නේ මේ පොඩ්ඩක් බලන්න. මම කොහොමද ගොඩක් තැන් වලදී මම මයින්ඩ් එක යූස් කරලා හදන තැන් ගොඩක් තියෙනවා. කොහොමද ඒක කරේ කියලා බලන්න. දැන් ගිය පාර පේපර් මම කියන්නේ ගිය පාර පේපර් එකේ ඇත්තටම අපි A4 කොලයක් ගත්තොත් A4 කොලෙන් භාගයක් වගේ තමයි පුතේ යන්නේ. හරියට මයින්ඩ් එක යූස් කරලා කරොත්. හරිද? ඒ නිසා දැන් මම ඔයගොල්ලන්ට දීපු පේපර්ස් ටිකම ගොඩක් තැන් බොහෝම සුවල්පයක් කරෙන්න මම නිකන්වත් හැදුවේ නැහැ. නිකන් මේ අපි හිතෙන්ම තමයි කරේ. දැන් මම කියන්නේ මේ අර නිකන් අර ලොකුමක් කියන එකක් නෙවෙයි මම කියන්නේ. හරිද? බොස්ෂිට් නෙවෙයි මම කියන්නේ. උතේ ඕගොල්ලන්ට ඒක ඒ මට්ටමට යන්න කියලා. හරිද? ඒ මට්ටමට එන්න කියලා කියන්නේ ඕගොල්ලෝ try කරන්න. try කරනවා කියලා කියන්නේ මුල් මම හැම වෙලේම කියනවා මුල් දවස් ටිකේ වර්ධිනවා. මුල් දවස් ටිකේ වර්ධින මයින්ඩ් එක යූස් කරලා තනියකින් හිතෙන් හදනවා මුල් දවස් ටික වර්ධින. නමුත් පස්සේ ඒක හරියනවා. ඕගොල්ලන් මම දැක්ක ලොකුම weak point එක හැමෝගෙම ස්පීඩ් එක. ස්පීඩ් එක මම දැන් අර දීපු එක්සෑම්ස් එකේම මම 24 කට්ටිය 25 කට්ටිය හැමෝගෙම දැක්කේ ස්පීඩ් එක මම. නැත්තම් ඔය පේපර් එකම නිකන් ඕගොල්ලන්ට ටයිමින් නැතුව හදන්න දුන්නා නම් ගොඩක් අය ඇත්තටම හදන පේපර් එකක්. ඇත්තටම හදනවා අනිවාර්යයෙන් මට ලොකු ෂුවර් එකක් තියෙනවා. මෙතන ඉන්න ගොඩක් දරුවෝට more than 75% ගන්න පුළුවන් ඒ පේපර්ස් දෙකටම ටයිම් කරලා දුන්නේ නැත්තම්. හරිද? හැබැයි ප්‍රශ්නේ තියෙන්නේ පොතේ ටයිමින් වල. ඒක අඳුර ගන්න ඕගොල්ලන්ගේ ප්‍රශ්නේ කොතනද තියෙන්නේ කියලා. ඕගොල්ලන්ගේ problematic area එක මොකද? It's your speed. You have to improve your speed. And speed එක improve කරගන්න නම් මේක use කරන්න වෙනවා. and දැන් නිකන් හිතන්න දැන් ඔයාලට මං කිව්වොත් එහෙම හඳගෙන හිතන්න කියලා ටක් ගාලා හිතන්න පුළුවන් නේද? ටක් ගාලා ඒක හිතන්න පුළුවන්. වැඩි නෙමෙයි. ඔයාලට මේ සෙනසුරු ගැන කිව්වත් ප්ලූටෝ ගැන කිව්වත් හිතපන් කියලා කිව්වොත් ඒව ටක් ගාලා ඔයාලට මයින්ඩ් එකේ මේ ඔළුවට එනවා. මෙන්න මේක තමයි ප්ලූටෝ කියන්නේ මේක කියලා මේක තමයි සෙන්සර් ඒ වගේ කියන්නේ ඒ ප්ලැනට් එක වගේ ඔළුවට එනවා. නේද? ප්ලැනට් එකට ෆිසිකලි යන්න ගොඩාක් කාලයක් ගියාට මයින්ඩ් එකෙන් යන්න එක ස්ටොප් පොයින්ට් එකක් යන්න. හරිද? ඒකයි කියන්නේ මයින්ඩ් එක කියන්නේ මාරම ස්පීඩ් එකක්. මයින්ඩ් එකෙන් අපිට ඕන තැනකට යන්න පුළුවන්. අපිට හිතන්නත් බැරි අඩු කාලෙකින්. හරිද? මයින්ඩ් එකෙන් අපි යන්න පුළුවන්. අපි ඕන තරම් යනවනේ නේද? අපි මනෝ ගහලා ඉන්නා කියලා කියන්නේ අපි ඕන තරම් මයින්ඩ් එකේ යන්න පුළුවන් තැන් තියෙනවා. හරිද? අපි එහෙම තමයි කරන්නේ. ඉතින් ඒක ඔයගොල්ලෝ යූස් කරන්න ඔයගොල්ලෝ ඒ ප්‍රෙෂර් හදන්න. ඒක මම කියන්නේ. හරිද? ඒ ඔයගොල්ලන්ට තියෙන ඇබිලිටි එක යූස් කරන්න ඔයගොල්ලන්ට ප්‍රෙෂර්ස් හදන්න. ප්‍රෙෂර්ස් මේ සෝල්ව් කරන්න. ඒක තමයි ඔයගොල්ලෝ කරලා නැත්තේ. හරිද? ඔයාලගේ මයින්ඩ් එකේ ඇබිලිටි එක තියෙනවා. ඕන කෙනෙක්ට ඒ ඇබිලිටි එක තියෙනවා. හරිද? නමුත් ඒ ඇබිලිටි එක ඔයගොල්ලෝ අඳුරගෙනත් නැහැ. ඒ ඇබිලිටි එක ඔයගොල්ලෝ යූස් කරනවා. අනේ ප්‍රශ්නේ. ඒ ඇබිලිටි එක යූස් කරන්න. දැන් ඔයගොල්ලන්ගේ මයින්ඩ් එකේ තියෙන ස්පීඩ් එක තමයි ඔයගොල්ලන්ගේ තියෙන ඇබිලිටි. ඒ ස්පීඩ් එක හරියට අර ප්‍රයෝග කරලා ගන්න. ඒ කියන්නේ ඔයගොල්ලෝ කියන්නේ නිකම්ම වාහනයක් ගෙදර නවත්තලා තිබ්බොත් එහෙම ලෙඩ වැඩිනේ පුතේ. නේද? වාහනේ පාවිච්චි කරන්නේ නැතුව ඒ වෙහිකල් එක වා ගරාජ් එකේ තිබ්බොත් එහෙම වෙහිකල් එක කොච්චර අලුත් වුණත් වෙහිකල් එක කොච්චර හොඳ වුණත් වැඩක් තියෙනවා. වැඩක් නැහැ. වැඩක් නැහැ. ඒක යූස් කරන්නෙත් නැහැ. ඒක යූස් කරන් ගත්තට පස්සේ ආයෙසර ලෙඩ වෙනවා. මොකද ඒක ඒ තරම් මේ පාවිච්චි කරපු නැති එක. ඕක තමයි වෙන්නේ මයින්ඩ් එකට. හරි. අපි මයින්ඩ් එක යූස් කරන්නේ නැති තාක්කල් මයින්ඩ් එක කරන්න බෑ. ඉතින් මයින්ඩ් එක යූස් නොකර ඉන්නේ. ඒක අපි හැමෝගම තියෙන දෙයක්. හැමදාම කියනවා පුතේ මේක මයින්ඩ් ගේම් එක. මේක මයින්ඩ් ගේම් එක. මයින්ඩ් ගේම් එකක් නම් අපි වින් කරන්න ඕනේ මයින්ඩ් එකම තමයි. අපිට හાર્ඩ් වර්ක් කරන්න ඕනේ නැහැ. හැම වෙලෙම කියන්නේ හાર્ඩ් වර්ක් කියලා කියන්නේ අපි විසින් හදාගත්ත දෙයක්. හරිද? මේ විශේෂයෙන් බයෝ කරන කට්ටියට තියෙනවා. නෝබම් මැත්ස් කරන කට්ටිය ඉන්නවා. මේ කියන්නේ මැත්ස් කරන කට්ටියට තියෙන ඇත්තටම නෑ හાર્ඩ් වර්ක් එක. හරිද? කෙමිස්ට්‍රි විතරයි තියෙන එකම දේ. ඒකට එකක්වත් නෑ හાર્ඩ් වර්ක්. හරිද? හાર્ඩ් වර්ක් තියනවා කියලා නම් ඉතින් එදලා මරන්න ඕනේ. ඒ තරම් වැඩක් නෑ. ඒ කියන්නේ හાર્ඩ් වර්ක් නැහැ මැත්ස් කරන කට්ටිය. හරිද? බයෝ කරන කට්ටියට මම ඉතින් ඒක තියෙනවා කියලා හිතනවා. මොකද බයෝ කියන සබ්ජෙක්ට් එක ගොඩක් අර මෙමරයිස් කරන්න ඕන සබ්ජෙක්ට් එකක් සහ ඒකේ ටිකක් අමුතු කතන්දර තියෙන සබ්ජෙක්ට් එකක්. හරිද? නමුත් මැත්ස් වේවා ෆිසික්ස් වේවා මේ දෙකෙන් එකක්වත් අර හાર્ඩ් වර්ක් කරන්න ඕන සබ්ජෙක්ට්ස් නෙවෙයි. ඒ දෙකම කරන්න ඕන පුතේ ස්මාර්ට් වර්ක්ස්. හරිද? කෙමිස්ට්‍රි මත ඒවා තමයි. නමුත් කෙමිස්ට්‍රි වල තියෙනවනේ ඔය ඉනෝගනික් කියලා කොච්චර කරත් පාඩම් කරන්න බෑ. දැන් අනිත් ඒවා ජෙනරල් එක ෆිසිකල් ඊට පස්සේ ඕගනික් ඒ වගේ පොඩි ලොජික්ස් තියෙනවා. පොඩි ලොජික්ස් තියෙනවා මතක තියාගන්න තියෙනවා. නමුත් ලොජිකලි යම් දේවල් තියෙනවා කරන්න පුළුවන්. නමුත් ඉනෝගනික් ජෙනරල් කතන්දරයට ආවට පස්සේ අපිට ඒක පාඩම් කරන්න වෙනවා. හරිද? දැන් HCl එකයි මොකද්ද සෝඩියම් හයිඩ්‍රොක්සයිඩ් එක තුනට පස්සේ ඉතින් ආයි හැදෙන්නේ කාබන් ඩයොක්සයිඩ් කියලා කියන්න බෑ. අපිට හිතන්නත් බෑනේ නේද? ඇයි ඒක හැදෙන්නේ දැන් ඇයි ඔක සෝඩියම් ක්ලෝරයිඩ් හැදෙන්නේ එහෙම අපිට කියන්න පුළුවන් බෑ. ඒක සෝඩියම් ක්ලෝරයිඩ් තමයි. හරි. ඒක අනිවාර්යෙන් ඒක එහෙයි කියලා පිළිගන්න ඕන දෙයක්. හරි. ඒ වගේ අපිට දැන් තියෙනවා. හරි. හැබැයි ෆිසික්ස් වල එහෙම මැත්ස් වලත් එහෙමනේ. හරි. මෙතන තියෙන එකම දේ ඔයගොල්ලෝ පළවෙනිම දේ ට්‍රැක් එකට වැටලා නැතිකම කියන්නේ. හරිද? ට්‍රැක් එකට වැටලා නැතිකම කියන්නේ පුතේ අපි හරි ට්‍රැක් එකේ හරි වෙලාවෙ ඉන්නවා. හරි ට්‍රැක් එකේ හරි වෙලාවෙ හිටියොත් අපිට හරි එන්ඩ් එකට යන්න පුළුවන්. ඒක නිසා දැන් මම මේ කියන්නේ පරණ දේවල් ගැන හිතා ඉන්න එපා. දැන් බලන්න ඕනේ කොහොමද අලුතෙන් එකතු වෙන knowledge එක අපි හරියට ග්‍රැබ් කරගන්න. ඒ කියන්නේ logically මේ knowledge එක ඔයගොල්ලෝ ග්‍රැබ් කරගන්න ඕනේ. මෙන්න මේක නිසා තමයි මේක වෙන්නේ. මේ නිසා තමයි මේක වෙන්නේ කියලා. ඊළඟට ඒක ඕගොල්ලන්ට හොඳටම ප්‍රූව් කරගන්න පුළුවන් තරක් තමයි self teaching කරන්නේ. දැන් මම අද මේ කියා දෙන යුනිට් එක ඒ යුනිට් එක ගිහලා self teach කරන්න. හරි. self teach කරාට පස්සේ ඔයාලට පුළුවන් අඳුර ගන්න self teach කරනවා කියන්නේ teach කරනවා කියන්නේ listening නෙවෙයි. දැන් ඔයා teach මාක් කරේ යුනිට් එක teach කරනවා නම් ඔයා මුලින්ම හදාගන්න ඕනේ teach කරන යුනිට් එකට අදාළව මේ අර මේක ස්කෙච් එකක්. හරි. මෙන්න මේක තමයි මම මුලින් මෙයාට කියා දෙන්නේ. මේක තමයි මෙයාට මුලින් කියා දෙන්නේ. මේක තමයි මම දැන් මම ඔයාලට කියා දෙන්නකොටම අනිවාර්යෙන් මෙතන ෆෝල්ඩර් එක හදා ගන්නවා. මම මේක තමයි ඔයාලට මුලින් කියා දෙන්නේ. මේක තමයි ඔයාලට කියා දෙන්නේ. මේක තමයි සෙකන්ඩ් කියා දෙන්නේ. හරි. එහෙම ඕල්රෙඩි හදාගෙන ඉන්නේ. ඇයි හේතුව? මොකද ඕගොල්ලන්ට ඒක ග්‍රැප් කරගන්න නම් මෙන්න මේක තමයි තියෙන ඕඩරේ තියෙන ඕන මේක තමයි ඕඩර් එකෙන්දී මම ක්‍රියේට් කරලා තියෙන්නේ. ඉතින් ඔයාලට පුළුවන් නම් ඒක ඔයාගේ විදිහට ක්‍රියේට් කරගන්න. ඒ කියන්නේ ඔයා තනි කරම සබ්ජෙක්ට් එක ගැන දන්නවා. නැතුව කරන්න බෑ. මම සබ්ජෙක්ට් එක ගන්න දන්නේ නැත්නම් මම හිතන්නේ මම ඉලෙක්ට්‍රොස්ටැටික් ෆීල්ඩ් දන්නේ නැහැ නේ. දන්නේ නැත්නම් මට ඕඩර් එක කොහොමද හදන්නේ? මම දන්නේ නැහැ. මම දන්නේ නැහැ නේද? අන්න ඒකයි ප්‍රශ්නේ. එතකොට හොඳට මතක තියාගන්න. අපි මොකක් හරි ටීච් කරනකොට මුලින්ම කරන්න ඕනේ ඒ ඕඩර් එක හදාගන්න. ඒ ඕඩර් එක හදාගෙන ඊට පස්සේ තමයි පුතේ ටීච් කරන්නේ. හරි. ඊට පස්සේ තමයි ටීච් කරන්නේ. දැන් එතකොට ඔයා self teaching කරනකොට ඔයාට improve වෙනවා. ඔයා මුළු යුනිට් එකේම නැත්නම් මේ section එකේ ඔයා අනිවාර්යෙන් අර මොකක්ද brief මේ sketch එකක් ඔයාලා අඳගන්න හුරු වෙනවා. ඊට පස්සේ අඳගන්න හුරු වෙලා ඔයා ඒ point එක තමයි ඔයා කියා දෙන්නේ. එතකොට ඔයා දන්නවා කොහොමද මේ යුනිට් එක හැදිලා තියෙන්නේ. එතකොට අඳුර ගන්නවා අනිවාර්යෙන් කොහොමද මම මේ යුනිට් එක බ්‍රීෆ් කරන්නේ කියලා. ඒක තමයි මාරම ක්‍රිටිකල් දේ. හරිද? කොහොමද පුතේ යුනිට් එක බ්‍රීෆ් කරන්නේ? හරිද? මොකද ගොඩක් ළමයිට මම දැන් ඔය මේ ළමයිගෙන් අහලා තියෙනවා මට එවන්න කියලා ඕගොල්ලන්ගේ ෂෝට් නොට්ස් කොහොමද ඔයා ෂෝට් නොට්ස් ගහනවා නම් ෂෝට් නොට්ස් කොහොමද එවන්නේ කියලා මට එවන්න කියලා තියෙනවා. සමහර වෙලාවට තියෙනවා මට. හරිද? ඒ ඒවා තියෙනව දැක්කහම මම දකින්නේ තමයි යුනිට් එක ගැන ලොකු අන්ඩර්ස්ටෑන්ඩින් එකක් නැහැ. ඒ නිසා දැන් ඕගොල්ලන්ට තුනක් පුළුවන් ඕගොල්ලෝ ඒ හදලා තියෙන මේ ෂෝට් නොට්ස් මට එවන්න. මම බලලා කියන්නේ. හරිද? ෂෝට් නෝට් එකක් කියලා කියන්නේ ඒ ෂෝට් නෝට් එක ලොජිකල් වෙන්න ඕන. ලොජිකල් වෙන්න ඕනේ කියලා කියන්නේ යුනිට් එක කොතනින්ද පටන් ගන්න කොතනින්ද ඉවර වෙලා තියෙන කියලා තියෙනවා. මේක නිසා මේක නිසා මේක නිසා මේක මේ විදිහට තමයි මේ කියන්නේ ලොජිකලි අරේන්ජ් කර ගන්න ඕනේ. මම ගොඩක් වෙලාවට try කරනවා ලොජිකලි තනිකර මේක නිසා මේක නිසා තනිකරම ලොජිකලි අරේන්ජ් කරලා ඔයගොල්ලන්ට දෙන්න. හරිද? අර සමහරවිට ඉතින් අර මේ මතක් වෙන කැලේ තිබ්බොත් එහෙම කියනවා. ඒ අරුණා මම සාමාන්‍යයෙන් ලොජිකලි අරේන්ජ් කරලා තමයි දෙන්නේ. හරි. හැබැයි මට වඩා හොඳට ඕගොල්ලන් අරේන්ජ් කරන්න පුළුවන් වෙන්න පුළුවන්. හරි. ඒ නිසා හොඳම දේ යුනිට් එක ලොජිකලි අරේන්ජ් කරගන්න හැම එකක්. ලොජිකලි අරේන්ජ් කරලා ටීච් කරන්න. ඒක නම් මාරම වටිනවා. ඊළ පස්සේ එකෙන් ඔයාලට අඳුර ගන්න ඔයා මුලින්ම අඳුර ගන්න ඔයාලට බැරි තැන. පළවෙනි එක ලොජිකලි අරේන්ජ් කරගන්න බැරි නම් ඒක අඳුර ගන්න. දෙවෙනි එක ටීච් කරගන්න බැරි නම් ඒත් අඳුර ගන්න. ටීච් කරනවා කියලා කියන්නේ පුතේ මෙතන වාගේ අර මේක නෙමෙයි මොකක්ද අර ලස්සනට කතා කරලා සුරංගනා කතා කියලා එහෙම දෙයක් නෙමෙයි. ලොජිකලි කතන්දරේ කියන එක විතරයි ටීච් කරනවා කියන්නේ. හරිද? එහෙම නැතුව නෙවෙයි. ඊළඟට ඒ දෙකම කරාට පස්සේ තමයි ඔයා කරන්න ගන්න ඕනේ questions. ඊට පස්සේ ඔයා questions කරන්න ගන්න tute questions කරන්න exam questions කරන්න. tute එක exam questions එක කරාට පස්සේ ඔයාට more than 85 තියෙනවා. more than 85 තියෙනවා නම් ඒ කියන්නේ ඔයා subject එක හොඳටම දන්නවා. හරි. ඒකයි හොඳට තියෙන්නේ. ඔයාට පුළුවන් නම් මොනවද මම ඒක බලන්නේ මෙහෙමයි. පුළුවන් නම් ඒ සබ්ජෙක්ට් එක දාලා මේ එක්සෑම් ක්වෙස්චන්ස් විතරක් කරලා. ඒත් එක්සෑම් ක්වෙස්චන්ස් විතරක් කරලා බලන්න මේ more than 85 තියනවා කියන්නේ. ඒත් තමයි. හරි. more than 85 කියලා කිව්වෙම මම අර ඉතුරු 50% දැන් සමහරවිට අපිට අර මැතමැටිකල් කතන්දර ටිකක් තියෙනවනේ. ඒ කියන්නේ ඒ දරුවට මැත්ස් වල තියෙන මොකක් හරි කතන්දරයක් නිසා ක්වෙස්චන්ස් වල දෙන්න පුළුවන්. හරි. ෆිසික්ස් සබ්ජෙක්ට් එකේ ප්‍රශ්නයක් නෙවෙයි තියෙන්නේ මැත්ස් වල තියෙන ප්‍රශ්නයක් නිසා වලදින්න පුළුවන් අවස්ථා තියෙනවා. ඒ නිසා මම හිතන්නේ 15% තිබ්බා. හැබැයි පාඩ more than 85 තියෙනවා. එහෙනම් අනිවාර්යෙන් වාගේ ටාගට් එකට ගිහින්. අන්න ඒක තමයි ටාගට් එක තියෙන්නේ. හරි. මුලින්ම සබ්ජෙක්ට් එකේ යුනිට් එකේ බ්‍රීෆ් ස්කෙච් එකක් ගහගන්න. බ්‍රීෆ් ස්කෙච් එකක් ගහගෙන ටීච් කරන්න. ටීච් කරාට පස්සේ ඒ දෙකෙන්ම ඔයාලට අඳුර ගන්න පුළුවන් වාගේ පොයින්ට්ස් මොනවද කියලා. ඒක තමයි අංක 1 සහ අංක 2 briefing and teaching. Secondly, you have to do some questions. Questions means tute questions plus exam questions, but I prefer exam questions. So if you can get more than 85%, that means you have very good knowledge about that particular unit. Okay. So that is a way of completing learning. Okay. That means where අපි කියන්නේ කටපාඩම් කරනවා කියන්නේ. කටපාඩම් කරනවා කියන එක කරොත් ඔය කරන්න බෑ. හරිද? මොකද අන්තිමට වෙන්නේ ළමයිට එක්සෑම් එකට යද්දී ටයිම් නැති වුණාට පස්සේ ළමයි කරන්නේ චිත්‍ර දිහා බලනවා චිත්‍ර උඩ දාගන්න. ෆිගර් එක තමයි උඩ දාගන්න. අන්න එතනින් දැන් තමයි ළමයිට වරදින්නේ. හරි අමාරුයි ෆිගර් එකක් උඩ දාගෙන ක්වෙස්චන් එකක් කරන්න පුළුවන්. කරන්න බෑ. දැන් ඔයා නිකන් ගිහිල්ලා බලන්න දැන් අර අපි යූස් කරන ඉක්වේෂන්ස් තියෙන හිතන්නකෝ අපි මොනවද මේක resultant force එක කොහොමද ඉක්වේෂන් එක මොකද ඉක්වේෂන් එක p r squared equal p squared plus q squared plus 2pq cos theta හරි ඔයාට මේ ඉක්වේෂන් එක මතක තිබ්බ උනාට වැඩක් තියෙනවා ජීවිතේට තියෙන ඉක්වේෂන් එක ඔයාලා ජීවිතේට වැඩක් ගන්න බෑ ඉක්වේෂන් එක ඔය ඉක්වේෂන් එක ක්වෙස්චන් එකක් එන්නේ නැහැ ඔය ඉක්වේෂන් එක ඇතුලේ කොහොමද තියෙනවද කියලා හිතාගෙන ඉන්න ක්වෙස්චන් එකක් තමයි හරි එතකොට අපි දැනගෙන ඉන්න ඕනේ ඒ ඉක්වේෂන් එක දැනගෙන ඉඳලා හරියන්නේ නැහැ ඒ ඉක්වේෂන් එක කොහොමද ඇවිල්ලා තියෙන්නේ කොහොමද මේක ඩිරයිව් කරලා තියෙන්නේ සහ කොහොමද මේක ඇප්ලයි කරන්නේ මොනවද කියන්නේ කියලා අපි දැනගෙන ඉන්න ඕනේ ඒ නිසා ඔන්න ඔය ටික පොඩ්ඩක් කොඩු දාගන්න ඕනේ පොඩි ඇඩ්වයිස් එකක් දුන්නේ හේතුව මොකද්ද මේ වෙලාවේ තිබ්බ අර එක්සෑම්ස් දෙකේදී ඕගොල්ලොන්ට පොඩ්ඩක් එක්සෑම්ස් දෙක මම දැක්ක විදිහට ඕගොල්ලන්ගේ ආන්සර්ස් ටික මම උඩින් පදගෙන තව ඔක්කොම මම කරෙක්ට් කරන්න ගත්තේ නැහැ මේ මම සාමාන්‍යයෙන් බලාගෙන ගිය හැම එකේම මම අඩුපාඩු දැක්කා හරි මම දැක්ක පළවෙනිම ප්‍රධානම පීක් පොයින්ට් එක හරි ටයිම් එකට කරලා තිබ්බ මම දැක්ක විදිහට ළමයි දෙන්නෙක් විතරයි. ටයිම් එකට කම්ප්ලීට් කරලා තිබ්බ ළමයි දෙන්නෙක් විතරයි. 25 විෂයද විදියට. හරි. ඒක නිසා ඒ කියන්නේ ඔක්කොම ටික කම්ප්ලීට් කරලා තිබ්බ ළමයි දෙන්නෙක් විතරයි. ඒ අඩුපාඩු තිබ්බා නමුත් කම්ප්ලීට් කරලා තිබ්බා ටයිම් එකට එච්චරයි. ඒතර එකට ටයිමින් කම්ප්ලීට් ටයිම් එකට කම්ප්ලීට් කරගන්න බැරිලා තිබ්බා. හරි. හරි ඒකත් පොඩ්ඩක් පොඩුවට ගන්න හරි හරි හොඳයි ඕකේ හරි දැන් හැමෝම එන්න okay please look at the board again now we are going to start the lesson again hard okay according to our previous explanation Puta if you want to charge if you want to make a charge object then you have to remove electrons from that object or you have to add some electrons you have to give some electrons to that object okay so because we cannot move protons we cannot move protons we can move only electrons so if you want to have charge object you have to remove electrons from that object or you have to add electrons to that object those are the two things you have to do suppose if you remove these electrons from this object you will have a charge object. You will have a charge object. Suppose you have, when I remove one electron, you have remove one electron. That means the difference between proton and electrons are equal. Are equal to the charge of one electron, no? Initially there were 10 protons and 10 electrons. 10 protons and 10 electrons. So you have removed one electrons. Now there are 10 protons and 9 electrons. 10 protons and 9 electrons. Okay. So the excess proton is 1. Normally, you know the charge of proton and charge of electrons are equal and opposite side. So what is the charge of electron? Tell me. What is the charge of electron?
-1.
Not -1. Minus 1.6 into 10 to the power minus 19 coulomb. I think you have done this one in your chemistry syllabus too. Done it?
Yes, sir. Yes, sir. I just gave a rough
Okay.
value.
It is a relative measurements, okay? So this is the charge of 1 electron, Puta. This is the charge of 1 electron. Charge of 1 proton. This is electron. Charge of 1 proton means the positive one of this one. Okay. So if you have 10 protons means, that means the entire charge is equal 1.6 into 10 to the power minus 19 times 10. Times 10. 10 electrons means minus this one times 10. Did you get my point? Yeah. Because charge of 1 electron is this one. Charge of 1 electron is this one. Suppose as this is a very long one, I can simply represent it as E. I can simply represent it as P. Or minus C plus C. Okay, minus C plus C. Minus C plus C. Okay, so if you have 10 protons means that you have 10 plus C's. If you have 10 electrons means you will have minus 10 electrons. Minus 10 electrons. So initially there were plus 10 electrons and minus 10 E. So initially the object was a neutral one. Okay. Plus 10 and minus 10 will be cancelled out, so neutral one. So after that, you have removed electrons from here. Then plus 10 electrons is unchanged. Now you have removed 1 electrons from here. Now minus 90. Therefore, the net charge is equal to plus E to plus C. To plus C. Then,
Yes.
so if you remove 2 E's, that means 2 electrons. The net charge is plus 2
Plus 2E.
plus 2E. Okay. Actually, when you are removing or adding electrons, you can remove or add by the entire electron. No, you cannot add or remove half electrons, 0.25 electrons. You cannot do that. No, if you add or remove electrons, you have to remove 1 electron. You have to remove 1 electron or 2 electron or 3 electrons. Therefore, you have to remove an integer number of electrons. Integer number of electrons. 1, 2, 3, 4, like this. You cannot remove decimal number. That means 0.5 electrons, 1.5 electrons. You cannot remove that one. No? You cannot take a half electrons. Right? So if you remove electron, it should be a whole electron. Okay. So the charge Therefore, the charge object, therefore, a charge object have a charge which is equal to the integer multiplication of electron. Integer multiplication of electron, no? Integer multiplication of electron. That means if you remove one electrons, the charge, the obtained charge is 1e. If you remove two electrons, the obtained charge means 2e. If you remove three electrons, the obtained charge is 3. Did you get my point? Hello?
Yes.
Therefore, the smallest charge is equal to the smallest charge.
It's 1e.
1 me, yes, 1 me. That means as a magnitude 1.6 into 10 to the power minus 19 coulomb. That is the smallest charge any object may ever have. Therefore, this is the smallest charge. So normally we are removing or adding electrons as a whole electron. We cannot add or remove portion of electrons. Therefore, the amount of charge is equal to the integer multiplication of charge of electron. Okay. So therefore, normally we represent it as Q equal NE. Q equal NE. Q means the amount of charge of an object, N means number of removed or add electrons. E means charge of one electron. Did you get my point? This equation?
Yes, sir.
Yeah, thank you. Hi. Now we can write the thing. Okay. Write in a new topic, new paragraph. If we need to charge an object, we have to remove or add electrons. From that object. We have to remove or add electrons from that object. We cannot add or remove electrons. Partially. We cannot add or remove electrons partially. Therefore, adding or removing, adding or removing, adding or removing of electrons can be done as a whole number, therefore amount of charge therefore amount of charge in a charge object is equal to number of electrons removed or added, number of electrons removed or added into charge of one electron. Charge of one electron. Therefore, amount of charge in a charge object is equal to number of electron removed or added into charge of one electron. Charge of one electron. So again, I got in Q equal N Q equal N. Q means this one. N means this one. E means this one. Q equal N. Q equal N. Okay. Note down. Write down this thing. Normally, we are using the actual values in electrostatic field, actual values with that. When it comes to particle physics, then we can use the relative values. Okay. But in this one, that means electrostatic fields, mostly we are using the actual values. Back. The charge of an electron. Charge of an electron is equal to minus 1.6 into 10 to the power minus 19 coulomb. Actually, minus 3%. Minus 3% the charge of an electron, okay? Because this is not a vector quantity. This is not a vector quantity. The minus 3% the charge of an electron, okay? Proton. 1.6 into 10 to the power minus 19 coulomb. Both are same in magnitude but different in sign. Shall I erase this one? Shall I erase?
Okay, sir.
Then write the example question. We can do some questions, okay? Using this equation. Number 1. Example number 1. How many electrons should be removed from an object? Should be removed from an object to have plus 1 coulomb charge. To have plus 1 coulomb charge. Plus 1 coulomb charge. Okay. I'll give you 1 minute. You have to use the equation. You equal any. You have to use this equation. Now, what is the charge of an object? Charge of the object. What is the charge of the object?
Plus 1 coulomb.
Plus 1 coulomb. Plus 1 coulomb. 1 coulomb is equal n times charge of electron, that is equal 1.6 into 10 to the power minus 19 coulomb. It means number of electrons. So number of electrons is equal 1 over 1.6 into 10 to the power 90. 10 to the power 90. So if you bring that to the numerator, then you will have 10 over 1.6 into 10 to the power plus 80. plus 18. N is equal 6 point galakene. So you do also can see and 6 96 14 is 6.25 again, right? 6.25. 6.25 into 10 to the power 18 numbers. Look at the board. If you want to give plus one coulomb charge, you have to remove this much of electrons. 10 to the power 18. 10 to the power 18 means, can you imagine that number? No, that is really huge. So plus one coulomb means coulomb one. Coulomb one means it's a very huge charge, very huge charge. You have removed this much of electrons to have that amount of charge. Okay. So think about this. Very huge number. And did you get my point? Did you get my calculation? Please.
Yes, sir.
Yes. Right there. But among the responses, did you get my calculation? Thank you. Thank you, Vijay. All right. Okay. Then I will give you another questions. Write this one. A wire contains a wire contains this is the first question. Second one. A wire contains 13.5 into 10 to the power 18 10 to the power 18 number of electrons number of excess electrons that means electrons than the protons. Sorry. Therefore, that wire contains that much of electrons than the protons. Question is, what is the total electric charge? What is the total electric charge What is the total electric charge carried by the wire? Carried by the wire. What is the total electric charge carried by the wire? The second question, second and third one. Third one. An object has a total charge, minus 4.8 microcoulombs. How many excess electrons? Does the object have?
Excuse me, sir. Can you repeat the third question, please?
Okay. An object has minus 4.8 microcoulomb charge. An object has minus 4.8 microcoulomb charge. How many excess electrons? Does the object have?
Thank you, sir.
The next question. A metallic sphere has a total charge of 3 microcoulombs. What is the number? What is the number of excess electrons on the sphere? Okay. Agar okay. Agar okay. Shall we do? My first question was our equation is Q equal NA. Alright. According to my first question, the excess number of electron is 13.5 times 10 to the power 18, no? 10 to the power 18. Then what is the total charge? That is the question. You know this one. N is equal 13.5 times 10 to the power 18. 10 to the power 18. And electrons, number of electrons is equal 1.6 into 10 to the power 90. 10 to the power 90. Okay. Now you have to calculate it. Now you have to calculate 13.5. 13.5. I can write that one as 2 times 1 over 1.5 into 10 to the power minus 90. Okay. And because I know 1 over 1.6 into 10 to the power minus 19 means 10 over 1.6 into 10 to the power 18. 10 to the power 18. And if you bring this minus 19 to the numerator, it will be plus 19. So plus 19. So yeah, you can write plus 19 as 10 into 10 to the power 10 into 10 to the power 18. So 10 over 1.6 means 6.25. 6.25 and 6.25. So I have this is equal to 6.25. I have asked 13.5. 13.5 means this one times 2. This one times 2. Right? Okay. And equal 1.6 into 10 to the power minus 19. So this one will be cancelled out. Answer is 2 coulomb. 2 coulomb. Okay. Did you get my point? Now?
Sir, I got 2.16 in.
What is the number you have substitute here? 1.6 so another one.
I took the same values and round off it from that 10 to the power 18 positive number is there, right? From that, remove the decimals and multiply it.
Okay.
To it.
But the thing is, 1 over 1.6 is 6.25. It is divided by 6.25 because 100 over 16. No? Okay, no, say 100 over 16. No? 100 over 16 means 96. Remaining is 4. Remaining is 4 means 1 over 4. That means 6.25. 6.25 means exact value, not approximate value.
Excuse me, sir.
Yeah.
Sir, how did 1.6 into 10 to the power minus 19 go to the denominator?
No. Actually, I have used my previous knowledge. Previous knowledge means which I get, which I calculate in our previous first question. Okay. In first question, there was 1 over 1.6 into 10 to the power 90 minus 90. So if I write this one as a, if I simplify this one, I can bring 10 to the power minus 19 to the numerator. Okay. So 10 to the power minus 19 means 10 times 10 to the power 18. Huh? Look at this one.
Okay, sir.
Look at this calculation. 1 over 1.6, 1 over 1.6 into 10 to the power minus 19 is equal 10 over 1.6 into 10 to the power 18. You have to bring 10 to the power 19 to the numerator. If you bring it into the numerator, it will become plus 19. Plus 19 can be written as 10 times plus 80. So if you multiply this one, the same value here. So this is equal 100 over 16. 100 over 16. 100 over 16 into 10 to the power 80. 100 over 16. 100 over 16 means if you multiply this one by 6, 96, the remaining is 4. 4 over 16, that means 1 over 4. 1 over 4 means 2.5. So this is equal to 6.25. 6 over 25. 6.25. Huh?
Okay, sir.
Sir, actually, what was the last argument you told, sir? How you got that 6.25?
Why would that? If you multiply 16 into 6, answer is 96. Then
Yes, sir.
the remaining is equal to
4.
4. Therefore, 16 over 16, 100 over 16 can be written as 6 plus 4 over 60. Right?
Yes, sir.
4 over 16 means 0.25. Yeah.
Yes, sir. Yes.
1 over 4. 1 over 4 means 0.25. Right?
Yes, sir.
This is not physics, this is maths, okay? එකපාර වලද මම කොහොමද මේක එකපාර දෙන්නේ කියලා මම මේක එකපාර දැම්මේ පුතේ මේ මම කලින් ක්වෙස්චන් එකේ මම කරේ මේකනේ මට ඒ මතකෙ තිබිලා මම දැම්මේ මගේ මතකෙ තමයි ක්වෙස්චන් එක හදලා දුන්නෙත් ඒ මතකෙ okay shall I erase
Sir, okay, sir.
others Alright. The second question, what was the second question? Can anyone tell me? Second question. 4.8. Minus 4.8. Again, Q equal NE. Q equal NE. Okay. In here, the charge is minus 4.8. Minus 4.8. Microcoulomb. Microcoulomb. So if you convert it to coulomb, 10 to the power minus 6. 10 to the power minus 6 is equal n times minus 1.6 into 10 to the power minus 19 coulomb. So n is equal 4 times 10 to the power 13. So not 4, 3. 3 times 1. 3 times. 3 times 10 to the power 30. Right? Okay. Then same question, the spherical object has 3 microcoulomb, no? Charge of 3 microcoulomb. So this is third, this is fourth. Q equal NE, Q equal 3 microcoulomb. So if I convert it to coulomb, 10 to the power minus 6 is equal 1.6 into 10 to the power minus 19. And so N is equal 3 over the 30 over 16 into 10 to the power 30. 10 over 30. So this one, 8, 15, 8 and 15. So 1.7 means 8, 70, say 60, yeah, 64, 6 means 6, or in 1.8 into 10 to the power 30, 1.8 again. 1, that means 7, 7 means 64, 8, 40 means 5, 1.85, 1.85, 1.85. Hello, 1.85. How to put it?
So shouldn't it be opposite side?
Approximate value. It's okay. You got 2. It's okay. Okay. Then, hi. Okay. Previously, we have discussed about the structure of material. That means atomic structure. According to that explanations, all the atoms are made of some chargeable objects. Okay, electrons and protons. Those are charges. And okay, so according to the behavior of those charges, that means mobility of those charges, materials can have different properties. Okay, actually, in our previous explanation, I have described about covalent bonds and metallic bonds. Okay? In covalent bonds, electrons are bound together by a covalent bond. Therefore, although there are electrons, those electrons cannot flow freely. But in metallic bonds, there's electron cloud. That electron cloud is a movable cloud. So those electrons can easily move here and there. Therefore, in metallic bonds, the electron can flow freely. But in covalent bonds, they cannot move freely. Okay. Therefore, according to the mobility of electrons, those materials show some different properties. That's about conductivity. Okay. So, if you want to have a conductor means a material that may conduct electric current. It's called as conductor. Okay. So if you want to create a conductor, definitely electrons should be easily moved. That means otherwise there's no any conductor, because if it is a current, definitely electrons can actually they can move very easy. And if there's a electric current. Otherwise, if not, electric current will not be appear. Okay. Therefore, according to the properties, that means ability of electron mobility. According to the ability of electron mobility, material can be divided into two major categories. First one are conductors. Second one is insulators and conductors. Okay, those are the two main materials that we can divide according to their electrical properties, electrical movable properties. Charge in conductors, charge can be moved very easily. In insulators, charge are bound together, therefore they cannot move very easily. And okay, not only these two, there is another subcategory, semiconductors, but we are not going to learn about semiconductors in electrostatic fields. We will learn that thing in electronics. So I'm not going to categorize that category under this one. Okay. Write down the topic. Types of material. This is a topic. Types of material. types of material according to their electrical characteristic. Types of material according to their electrical characteristic. Okay, write down on this. Hello. We can categorize materials into two main categories. According to their electrical properties. Materials. So we can divide them into two main categories. What are those? Conductors and insulators. Conductors and insulators. Those are the main two categories in if we divide the materials according to their electrical properties, those are the two main categories. Right. In addition to these two, there's another type of material. There's another type of material called semiconductors. It will be discussed under electronics. First up subtopic, conductors. Okay, if we consider about conductors, conductors allows electrons to move very easily within that material. Okay, conductors allows electrons to move very easily. So due to that reason, if we apply some potential difference or some kind of force across the conductor, electrons can easily move. Okay. Therefore, in conductor, the most important property is electrons can flow through a conductor. electrons can flow through the conductor. Okay. Then what about in insulators? Insulators can or not? Can anyone tell me? Insulators?
They do not travel electrons.
They do not.
Gives the medium to travel the electron through it.
Okay. Very good. Yeah. Actually, a conductor allows electrons to move freely. But insulators, they do not allow any electron to flow freely because they are bonded together by covalent bonds. Okay. Okay. We have written the topic, no? Type of material according to the electrical properties.
Yes.
Okay. Okay. Electrical properties it was say then this subtopic conductors. Write down under conductors. Conductors allow electrons to flow very easily. Conductors allow electrons to flow very easily through it. Most of the conductors are metals. So they have metallic bonds. They have metallic bonds. There are free electron clouds. In metallic bonds. Due to this reason, electrons can move very easily. Example for conductors. Are metals. So if we take metals, there are 3 electrons. There are 3 electrons that can move very easily. So you have to write that one, conductors, metals. Then this figure. They write a topic, insulators. Insulators do not allow electrons to flow through it. Then most of the insulators insulators consist covalent bonds. Okay. Then if this is a material, then there is a covalent bond. Megane. have right under this. Mass of the electrons, so mass of the materials, mass of the materials mass of the materials which are categorized under insulators, which are categorized under insulators which are categorized under insulators consist of covalent bonds, consist of covalent bonds. Therefore, it is very hard to remove an electron. It is very hard to remove an electron it is very hard to remove an electron as they are bound together, as they are bound together as they are bound together by covalent bonds, by covalent bonds.
Excuse me, sir, can you repeat again from remove an electron?
Therefore, removing therefore it is very hard to remove an electron from insulator as the electrons are bound together, by covalent bonds, Hey, anyone there's a problem. So, can we charge or can we give a charge to an insulator? Insulator charge is full of there.
Yes.
Yes. So what is the reason?
Because we can remove or add electrons
Yes. Actually, in insulator, they do not allow to flow electrons. Okay. In insulators, they do not allow electrons to flow. Okay, but we can remove electrons from lattice. We can remove if we give enough amount of heat. We can easily remove. We can easily remove electrons from lattice. But the thing is, it is not movable electrons within that material. Okay, it is not a movable electron within that material. Did you get my point?
Yes.
Therefore, insulators means they do not allow to flow materials, so flow charge objects through that material. Okay, but we can remove any electron. We can remove any electron. Okay. Take that. 13 another paragraph. Insulators are not the material insulators are not the material that cannot charge. They can charge.
Sir, insulators are not the materials that cannot charge.
That cannot charge, and full stop. Then they can charge. Charge means we can give a charge. They can charge. But insulators do not allow charge flow. Do not allow charge flow through the material. Okay. And everyone, now we are going to complete today's class. Please tell me, do you have any questions to be asked? Or are you clear with all the things? Huh? Are you clear with all things? Next week we can start electrostatic induction. So tell me, are you clear with all the things, especially about the insulators as well as conductors? Tell me about it.
Yes, sir.
Yes, sir.
Like today. So that means we can accomplish today's class. So tomorrow there will be heat lesson. So please may go through the previous lessons and may come to the class tomorrow as usual. Tomorrow morning from 8 o'clock there will be a session for 2025 students. It's about linear motion. So after that there is another class for 2025 in non-medium students. And in heat lesson will be from 7:30 to 10:30. Okay. Hi. So you can complete today's class with that. So good night. I bought.
I
I belong,
thank you,
sir.
sir.
Sir, excuse me.
Yeah, come down.
Sir, actually, I'm having a doubt, sir. In the calculation that we did under Q equals NE, actually, sir, when we are directly multiplying 13.5 into 1.6, and when we did the method according to you, like 2 into 1 divided by 1.6 to get 13.5, the answers are two different answers, sir. When doing according to yours, it's 2 coulomb, and when directly multiplying, it is 2.16. No?
What was the question? 13 point
13.5 into 10 to the power 8.
10 to the power
8. 18, sir. Sorry, 18.
18. And
Uh,
so we can write this one. Look at this one. If you may, 1.16 into 10 to the power minus 19, it is equal to 6.25 into 10 to the power 18. No, this one
yes, sir.
you can understand.
Yes, sir.
So, if you multiply both side by 2, then you will have this one. Okay. So then, if I apply this one, values to equation Q equal NE, have this is N, no? This is N.
Oh, no.
13 point 10 to the power 18 into E means 1.6 into 10 to the power 19 minus 90. And so those are two things you have. Then,
Yes, sir.
suppose, all right, now I'm not going to use this value, use this method, and I will multiply this one as the using the loan method. Okay. So if you use the loan method, 18 will be cancelled out with this one. Okay.
Yes, sir. Yes.
Okay.
Directly when multiplying, sir, the answer is 2.16.
No. 13.5 into 0.1. Okay. 13.5. 13.5. 116, remember? 13.5. That means one. Yes. 13560. So 30. That means the remaining 3, 18, 21, 2, 6, 8. No? 0, 5, 3, 1. 0, 6, 1, 2. Well, 2.16. No? Your answer is 2.16.
When it's done according to your method, sir, the answer is 2.
Yes. 2.16, no?
Yes, sir.
Your answer is 2.16. My method is this one. Ne?
Yeah, so even that is correct, Nehru, sir. But why is the answer different like 2 and 2.16?
Actually, there is a small approximation. Ne? Because 1.6 means Buddha, it is not the actual value of electrostat. No? Right?
Okay, sir.
Because there is a 1 point. But take at 135, 13.5, 14.5. Hari. Mama yaar. This should be 12.5, not 13.5. Hari.
Okay, sir.
I make a multiplier and 12.5. It should
Yes, sir. 12.5.
be 12.5.
Okay, sir.
12.5.
Now, okay. Then, sorry.
Okay, sorry. That's it.
Thank you, sir. Okay, thank you, sir. Good night, sir. Thank you.